Yo, welcome back to another video, guys. Welcome back to another video. And today's video, you know what, I had to record this video twice. This is my second time because I was making a video about this math before, whatever this question, but my audio was off, so yeah. But don't worry, guys, I'm back in with positive energy, and today I've got 2 new markers so you can actually read it. Now we're going to be solving a quintic, no actually, yeah, a 6-degree polynomial, okay? I think it's a quintic. Yeah, it's called, septic. Yeah, I don't know it. I think, yeah, this is a 6-degree polynomial, okay? Now this will have, the zeros of this polynomial will have 6 roots, okay? And you know, this was from BRBP Math Basics. He has a YouTube channel. He's a cool guy. He teaches college math and stuff. He does every math topic basically, from elementary to like college level videos. You know, it's a cool thing. So I saw the video on his channel. I solved it by myself, and I got roots. But the thing was, I used a different method, and he used a different method. Basically, what he uses, he factors this by adding / subtracting terms to get a perfect polynomial, a factorable polynomial. But what I used factoring by grouping method. So I created groups. I factored each term which I got, and then I saw the common factors from each factored term I got from each group term, and then I took the common factor and factored and I set each factor equal to 0. That's what I do here. Basically, in here what I did was, you see x to the 6 and minus 1. I made factors from this. My second group pair was this. So it was factored like this: x to the 6th power minus 1 plus 2x to the power 5 plus 2x to the power 4 minus 2x squared minus 2x minus 1 equals 0. Yeah, so that's how it was basically. And what I did was I factored it. So basically, because I thought, you know, x to the 6 and x to the 6th power minus 1 is factor, and this is also factor. We can get a common factor of, we can get a fact. So why did I put minus 1 here? I already put that, sorry. Okay. So yeah, as I was saying, yeah. So look, from here, we can factor x to the 6 minus 1, and we can also factor this second term that I grouped using, by factoring out the common factor. There's 2x. Okay, so here's our event actually. Look, in here, first let's focus on x to the 6th power minus 1. And I wrote it like this: x cubed squared minus 1 cubed 1 cubed squared. Now I'm thinking, why did I do that? Because this is a difference of squares. Look at this. This looks like a difference of squares. And why did I put 1 cubed here instead of 1? You'll see later. You can write this as x cubed plus 1 cubed into x cubed minus 1 cubed. Because in here, this is our a. You know the a squared minus b squared formula? So a squared minus b squared is equal to a plus b into a minus b. That's the formula basically. And this is, and here we have a as x cubed and b as 1 cubed or 1. But you know why I kept it at 1? The reason was being that, see, you know the sum of cubes identity? I can factor this. I can factor these two factors more further, each factor. So what I get here is that I get, see, x cubed plus 1, a cubed plus b cubed is equal to a plus b. So x plus 1. Now basically our a is x. Yeah. Our a is x and our b is 1. Same with x cubed minus 1 cubed. Our a is x and our b is 1. So first we're gonna apply the sum of cubes identity, and then we'll do the difference of cubes. Okay, So look, basically, we know that a cubed plus b cubed is a plus b first. A is x, b is 1. Then you have then next second factor will be a squared, x squared, minus ab. A into b is x into 1, which is x. So minus x plus b cubed. B cubed is 1 cubed, which is 1. Okay, and then and then after that, I think I can erase this. And then look, now what do we get from there? We can factor. Now we can factor out the difference of cubes. This was the sum of cubes. Now we're going to move on to the difference of cubes. So look, in the difference cube, a cubed minus b cubed is a minus b first. So x minus 1. Then, because a is x, b is 1. And then we have a squared, x squared, plus ab, plus x into 1, plus b squared, 1 squared, which is 1. So this is a factored form of the first group term that we got. Okay? So it's x plus 1 into x squared minus x plus 1 into x minus 1 into x squared plus x plus 1. Okay? Now, if we make a line, now let's go to the second factor. The second group term that we made, is this: 2x to the power 5 plus 2x to the power 4 minus 2x squared minus 2x. Okay? So when you're factoring this, look, I can factor out 2x. This is just 2x. This is 2x into x to the power 4 plus x cubed minus x minus 1. Why this? 2x into x to the 4 plus 2x to the power 5. 2x into x cubed is 2x to the power 4. 2x into minus x is 2 minus 2x squared. And 2x into minus 1 is minus 2x. But do you see that we can factor x cubed plus x to the 4 plus x cubed and minus x minus 1? Look, I can write it like this: 2x into x cubed into x plus 1, minus 1 into x plus 1. You know, why I write like this? Because I can factor it now. These both, when we factor this x4 plus x cubed, and then we factor minus x minus 1, they both shall confactor x plus 1. These two terms. Now, because minus 1 into x plus 1 is minus x minus 1, x cubed into x plus 1 is x to the 4 plus x cubed. So I can write this as, finally, 2x into x cubed minus 1 into x plus 1. Now, if you notice here, I can factor x cubed minus 1 again. So you know what? I think I have some space here. Let's write it here. So if you know the identity, then we have, look, this 2x into a x cubed minus 1 cubed, a cubed minus b cubed is a minus b first. Okay, so x minus 1 first. Like this. Sorry. First x minus 1, which is a minus b. Then x squared, a squared, x squared, x squared, and then we have plus ab plus x plus 1. Okay, so that's how we did the difference of cubes. AB squared is 1 squared is 1. So now, and then we have to also make sure to keep the factor x plus 1 here. Okay, so that's the factor that we factored out basically. And now, there we have it. Now let me make some space here. I can write the factors for both of these. And now we can clearly see some common factors here. But first, let me erase it to make some space. So because now I wrote this, we factored each group term. This is our first factored term. first factor, and this is the, we have lots of factors here, but for a first group term, this is our like first like factorization for our first group term, and this is our second one for our second group term. Now I can see that there are some things common here. Take a look. X minus 1, x minus 1, x squared plus x plus 1, x squared plus x plus 1. Then we have what else? We have x plus 1 here, then we have x plus 1 here, and that's why the only two terms missing here are 2x and x squared minus x plus 1. Okay, so those are the only terms missing. So that's the thing. Okay, and now we can factor it with the common terms. So first let's write down x plus 1, x plus 1 into x minus 1 into x squared plus x plus 1, okay, into the what are the terms that are not common? X squared minus x plus 1 plus 2x, okay, and is equal to 0. Now we can see that we can simplify the bracket inside here. We multiply this thing by this. So when we simplify, we get 2x minus x is just positive x. So we actually get x squared plus x plus 1. I'm just keeping the brackets like this so I can show you that I simplified inside. Now we have two common here. What does this mean though? I'll let you know first. Now see, now we just have to let each factor equal to 0. So A, remind like this, that's a zero product property rule. X plus 1 equals 0. We get x equals minus 1, first real root. Then after that we have x minus 1 equals 0. Then in which we get x equals 1. Then from here we get C, which is x squared plus x plus 1 equals 0. And D, again, which is x squared plus x plus 1 equals 0. Now I can solve this equation. You can use whatever method you like, comparing to a square using the formula, or you know what, factorization. But you know what, I actually found this. You know how I remember this? I remember the roots because in the, you know, when I made the video on cube roots of unity, x cubed equals 1. I know the factor x squared plus 1 plus x equals 1. I know the factor we said equal to 0. So I know all the cube roots of unity, and these roots are part of them. That's why I know the answers to the roots of these, which are the same, this equation. So in this one we get x equals negative 1.2, okay, plus or minus, plus or minus, okay, the square root of 3 upon 2 into I. Now here I is the imaginary unit, as you all know of, okay. Now for this one, this is same, x equals negative 1.2 plus or minus the square root of 3 upon 2 into I. Okay, so yes, these are the roots. Now I'm thinking in this one we have, for part C and D, these roots are the same, minus 1.2 plus or minus the square root of 3 upon 2 into I. So this means, you know what this means? This means that when we graph this equation, this 6 degree equation, this means that these two roots, each one of these roots, the positive and the negative version, they touch the x-axis twice. That means like they once like this and twice on the graph. So that's why we have two of these things. So when you get this, you have to write in bracket multiplicity 2. Okay, So I'm just going to write the final answer on the board for all these, for this equation. Okay guys, so these are the final roots. So we have two real roots, x1 equals minus 1 and x2 equals 1. Then we have x, now I put comma 3 for it because third and fourth root, negative 1.2 plus square root of 3.2i, multiplicity 2 means the same root is appearing twice. Now x and the fifth and sixth roots, x5, 6, these are equal to, is negative 1.2 minus square root of t minus square root of 3.2 into I. This is the quantity of x of the previous root, but multiplicity of 2, because negative 1.2 minus square root of 3.2i is also as well appearing twice. So that these are 6 roots. This is when you graph them, they touch on the point twice. That's why multiplicity of 2. That's why we put multiplicity of 2, and with the help of solving these, setting each factor equal to 0, we got the roots. So like, also if BRBP Math Basics is watching this video, let me know how it is. Let me know how you like my factoring with grouping method, factoring by grouping method. Because I was a different method I did. Because in the comment section of the video, no one did the same method I did. I was the only one that commented the method I did, and I want to show you guys the method because it's pretty damn cool, Yeah, that's why. So yeah, have a good day, enjoy your day, and you know what? Hope you guys can learn something new today, like multiplicity, and how to solve 6-degree equations. And yeah, peace out, and yeah, like and subscribe to the channel for more content like this. Peace. Bye bye.